In just 7 minutes, let's go through some examples of basic utilization of Solana Web3.js. So Solana Web3.js is among the most popular methods of connecting to the Solana blockchain and building applications. Because of this, it's really important to know, number one, what the library is capable of, as well as number two, how to actually use it. So in an effort to make this topic a little bit easier to digest, I'm going to go through 3 key examples of Solana Web3.js utilization. I'll start by minting an SPL token. I'll then go through how you can very quickly send a normal SOL transaction. And finally, to complicate it just a little bit more, I'll go through the process of delegating SOL natively through Solana Web3.js. So let's go ahead and jump right into it. We're going to be covering a lot of ground here, so I'm going to be going through things fairly quickly. But if you'd like to dive more into these specific concepts, I do already have a video on both minting SPL tokens and sending a transaction with Solana Web3.js that you can find linked below this video if you want to deeper dive into these key concepts. But for now, we'll need to import a few key libraries to get started. We'll import, of course, Solana Web3.js, we'll import SPL token, and we'll import base58. All right, so now we have our key libraries. These are the only 3 that we'll be using here: Solana Web3, SPL token, and base58. We'll be using Solana Web3 for most of this, of course, as the sort of base layer connection and interactivity layer with the Solana blockchain. We'll be using SPL token for the minting and token account process, and we'll be using base58 for the private key decoding. All right, so now I'm going to throw all of our code into a main asynchronous function. So we can just go ahead and open up an asynchronous function. We can go ahead and start by defining our connection variable. This will, of course, as the name suggests, be the variable that we use our RPC endpoint in to actually connect to the Solana blockchain itself. New Solana Web3.connection. And then in here, we'll need to paste in our RPC endpoint. In my case, I'll be using Chainstack. So I've opened up my Chainstack console here, click on Get Started, select Solana and Solana mainnet. Then next. I'm going to keep this as standard and deploy a globally load balanced Elastic Full node. We just recently released global Elastic nodes for Solana, which means that this node that I deploy will be located globally rather than locked to a specific region. We'll keep the name as node 1 and next. Then we can click on join network. Now we can head into here and copy our HTTPS endpoint. We'll throw that into a string here, and then we'll also throw in our WebSocket endpoint by defining WS endpoint, and then in here, pasting in the WebSocket endpoint as well. We can go ahead and move on to defining our main account. We can call this wallet key pair and set it equal to Solana Web3.keypair.fromSecret key. Here we can make a new uint8 array. We can pass in our base58 library, then the decode method on that, and then in here we can throw in our private key. All right, so now that we have our main wallet, let's go ahead and quickly run a balance call on it just so we can know how much SOL we're working with. We can create a balance variable, set it equal to await connection.getBalance, and then pass in the public key of the wallet that we just defined. And then we can go ahead and log the balance by just doing balance, and then divided by Solana Web3.lamports per SOL. And before we continue, let's go ahead and run this code, make sure that it works. So we can go below here, just quickly call our main function. And as you can see, we have about 0.3 SOL in our wallet. So let's continue on to the first major example of Solana Web3.js utilization, which is minting an SPL token. We can start by defining a mint variable and setting this equal to await an SPL token and the create mint method. And here we can start by passing connection in the wallet key pair, which includes our private key, of course, and the wallet key pair.public key. And we can throw a null here. This is the freeze authority. We'll do 9 decimals and then fill in some of our unused parameters as well. And then at the end here, we can throw in SPL token.token program ID. From there, we can go ahead and create a token account, SPL token.get or create associated token account. And now here, similar to the create mint call that we did earlier, we can pass in connection, wallet key pair, and then the mint object, and then finally the public key of wallet key pair. We can now move on to actually minting the token itself, and we can do this outside of a variable just by doing await SPL token.mint2 connection, wallet key pair, mint, then the token account that we just defined and its address, and again the public key of wallet key pair, and then the number of tokens that we'll be minting. In this case, this represents about 1,000 tokens. We've created our mint object, which runs the create mint method on the SPL token library that we imported. We created a token account, and we minted the tokens to our wallet. Before we continue, we can go ahead and run it and make sure that it works. All right, it finished running. I received 1,000 tokens, which is the SPL token that we just created and minted. All right, we can now move on to something that I've covered in the past. It's very simple. This is sending a basic SOL transaction from one address to another. Before we get started, we'll actually need a second address to send the SOL to. In this case, I'm going to generate a fresh wallet and call it second wallet key pair. This will be set equal to Solana Web3.keypair and then .generate. So let's go ahead and define a transaction object. This will be a new Solana Web3.transaction, and then .add. Can open this up. And here we'll need to call Solana Web3.systemprogram.transfer, and then we can fill in the basic information of the transaction. To start, we'll need from pub key. This will be the public key of wallet key pair, which is of course my own wallet. We'll need to pub key, which is the recipient of the transaction. This will be second wallet key pair.public key, and then we'll need the value of the transaction, which will be defined in lamports. For this, I can do Solana Web3.lamports per SOL, and then I want to send 0.001 SOL in this case. And then we can go ahead and send the transaction itself and save the signature into a variable called signature. Solana Web3.send and confirm transaction. And then here we can put connection, the transaction object, as well as our wallet. So perfect. Now we're at a point in the script in which when we run this, it'll create a new SPL token and mint 1,000 of those tokens to my wallet. And it'll also send 0.001 SOL to a fresh wallet that we generate in second wallet key pair. So before we continue on to the third example, which is delegation, let's run this and make sure that it works. All right, so let's check my Phantom wallet. And there we go. We can see I received 1,000 SPL tokens. It's a new token from the last time because we're running it again, as well as sent 0.001 SOL. All right, so now let's move on to our final example of Solana Web3.js utilization. This will be the most complicated one yet, so let's jump right into it. So this will require 4 key components. We'll need to first create a stake account. We'll then need to initialize the transaction for the stake account creation. We can then delegate our stake, and then finally initialize the transaction for delegation. So let's go ahead and start by creating the stake account. We can do this with a variable called stake account in Solana Web3.keyPair.generate. Then we can create a variable called create stake account instruction and set that equal to Solana Web3.stakeProgram.create account. And here we'll fill in a few key details such as from pub key. That will of course be our wallet. We do stake pub key, which will be the public key of the stake account. And then we can set the authorize parameter to new Solana Web3.authorize and wallet key pair.public key and wallet key pair.public key again. We can then go ahead and define the amount of Solana that we actually want to stake. In this case, it'll be 0.02. Let's now go ahead and initialize the transaction for the stake account creation. We can call this create stake account transaction. And similar to the SOL transaction, this will be a new Solana Web3.transaction and then .add and the variable that we just created. Under here, we'll need to set a few additional parameters such as recent block hash and fee pair. We do create stake account transaction.recent block hash, await connection.get recent block hash, and then .block hash. We can also set the fee pair.fee pair, wallet key pair.public key. And finally, we can run a partial sign call on the transaction object with the newly generated stake account. We can go ahead and push the transaction to the network. Solana Web3, send and confirm transaction. Then we can pass in connection, create stake account transaction, as well as our wallet and the stake account. And then finally, we'll need to build and send the delegation transaction. We'll first need to define the public key of the validator that we're delegating to. We can set this equal to new Solana Web3.public key and then pass in the public key. We can also go ahead and create a delegate instruction variable and set that equal to Solana Web3.stakeProgram.delegate. And then here we can set a few parameters such as the stake pub key, which is of course the stake account that we defined above, the authorized public key, which will be the public key of our wallet, as well as the validator public key that we defined above. Now we can go ahead and push that transaction to the network. So we can create a variable called delegate transaction. And similar to the last two examples, we can create a new Solana Web3.transaction and then add the delegate instruction variable that we defined above. Similar to the stake account creation, we'll need to define a few extra parameters such as the recent block hash and the fee pair. We can do this with delegate transaction.recent block hash and set that equal to the same value as up here. And similarly, we can do delegate transaction.fee pair equals the public key of our wallet. And then we can go ahead and sign this transaction. Finally, we'll push the transaction to the Solana blockchain. We can pass in connection, the delegate transaction object, as well as our wallet. So what we've done is we've imported a handful of base libraries. We've defined a connection to the Solana blockchain through a chainstack endpoint. We've imported our wallet, found the balance of that wallet, minted an SPL token, sent a SOL transaction, as well as staked 0.02 SOL. So now that we're done and we're ready to go, let's run it and see if it works. All right, so let's open up Phantom and check it out. And it looks like everything worked. We received the 1,000 new SPL tokens that we minted, sent 0.001 SOL, and staked 0.02 SOL. This video was episode 11 in Chainstack's bite-sized building series, in which we run through complicated concepts in just a few minutes. If you'd like to watch more bite-sized building videos, then you can do so with the link below. Additionally, in this video, I launched a Chainstack Global Elastic Solana node. If you'd like to learn more about Chainstack Elastic nodes, the link to that will also be below this video.